The history of capacitance and capacitors roots in the 18th century. Today, let's start with the exploration of the fascinating journey of capacitance and capacitors throughout history. The story of capacitance begins in the 18th century with the work of an ingenious scientist named Edward George von Callist. In 1745, Callist, a German clergyman, made a fascinating discovery. He found that when he connected a small conducting sphere to a large one using a wire and charged a small sphere, it retained an electric charge. This was a crucial observation that laid the groundwork for the concept of capacitance. However, it was not until 1746 that a fellow scientist, Peter von Maschenbach, a Dutch physicist, further developed this idea. Maschenbach, along with his assistant Andreas Cuneus, independently replicated Callist's experiment. They used a glass jar partially filled with water and coated the inner and outer surface with metal foil. Lender jar, as it came to be known, became the first practical capacitor. News of Leyden jar spread rapidly, capturing the attention of scientists across Europe. It became an essential tool for storing electricity. Notably, Benjamin Franklin in the American colonies and William Watson in England both made significant contributions to the understanding of capacitance. Fast forward to the 19th century, and the theoretical framework for capacitance was established by renowned scientists like Michael Faraday and George Simon Ohm. Faraday introduced the concept of electric field lines, while Ohm developed mathematical equations describing the behavior of capacitor in a circuit. The evolution continued into the 20th century. With the advent of electronic technology, capacitors found widespread applications in radios, televisions, and emerging electronic devices. The development of new materials and manufacturing techniques led to a diverse range of capacitor types, each designed for specific purposes. After briefing historical exploration, now let's try to understand what it exactly is. At its essence, capacitance is like a central property of a certain material, allowing them to store electrical energy into form of electric charge. Think of it as a reservoir for electricity, capable of holding and releasing it when needed. Now imagine a capacitor as a magical device within an electrical circuit. It consists of two conductive plates separated by a non-conductive material, often referred to as a dielectric. When we introduce a voltage across these plates, something fascinating happens. The two conductive plates spring into action. One plate accumulates a positive charge while the other takes on negative charge. The dielectric between them ensures they don't get too close and conduct electricity rapidly. Here is where the magic comes alive. The capacitor now holds the electric charge, ready to unleash it when the circuit calls for it. It's like a reservoir filling up with electrical energy, potentially waiting to power a device. In more technical terms, capacitance is the measure of a capacitor's ability to store charge per unit voltage applied. It's measured in farads. The unit farads is named after the brilliant Michael Faraday. So far, as we have some sort of understanding about what capacitance and capacitor is, now let's discuss some of its daily life applications. Power supply filtering. Capacitors act as a smoothing agent in power supplies. They absorb fluctuations in voltage, providing a stable and continuous power output to electronic devices like computers and audio equipments. Signal coupling and decoupling. Capacitors facilitate the transfer of alternating current signals while blocking direct current. This property is crucial in audio systems, allowing the transmission of sound signals without the interference of constant voltage. Timing circuits. Capacitors are fundamental in creating time delays in electronic circuits. They control the rate of charging and discharging, influencing the timing of events in applications such as flash photography, timing circuits in appliances, and oscillators in electronic devices. Curiosity has its own reason for existing, which leads to questions about everything encounters it. Here, we have some of those questions. Let's have a look. How does a capacitor work? Think of a capacitor as an electrical storage device. It has two plates, separated by a non-conducting material. When voltage is applied, one plate accumulates a positive charge and the other takes on a negative charge. The separation ensures controlled energy storage and release. How is capacitance measured? Capacitance is measured in farads, named after Michael Faraday. 1 farad is the capacitance when 1 coulomb of charge is stored with 1 voltage across the capacitor. Capacitors in electronics typically have capacitance values in microfarads or picofarads. Can capacitors store energy for a long time? Capacitors can store energy, but it's important to note that they can discharge over time due to factors like internal leakage or the nature of dielectric. Long-term energy storage is often better suited for other devices like batteries. And that concludes our exploration of capacitance and capacitors. From their fascinating history to their everyday applications, these remarkable components play a hidden but crucial role in powering our world. Whether it's filtering noise in your headphones or storing energy in your laptop, understanding capacitance opens up windows into the invisible force that shape our technological landscape. Remember, this is just the beginning of your journey. As you delve deep into the world of electronics, you will discover even more ways that capacitance shapes our lives. So, keep exploring, keep questioning, and never stop being amazed by the hidden power of electric charge.